Okay, what we have here is kind of a scale mock-up of a typical foundation area in a home. And to put this together to show one of the biggest areas of heat loss through both infiltration and conduction. This would be, in this case, this is the basement wall. These are the floor joists that are running across that basement area. This is the subfloor above it. This area on this side is what they call the band joist. This is basically just usually a 2x10 or a 2x12 plank on edge, and then the floor joists run across from it. So you can see this would be the outside wall. This would be the inside surface in here. Really all you've got separating the indoor environment from the cold outdoors is 1.5 inches of lumber, and with nothing really sealed up to keep the cold air from leaking in. What you might see, if you've got an existing home, you might see a case like this where somebody's insulated this area with fiberglass insulation. And I wouldn't recommend doing that. If you've got fiberglass in there and you can get at it, remove it and insulate it with this foam and silicone the way I'm going to show you today. What you want to do is to seal up along the area between this band joist and the subfloor, and then along both of these edges and along the bottom. If you've got a block or a concrete foundation, you might actually have an additional board laying flat on this top area. You definitely want to seal up between that and the concrete foundation as well. So we'll just get some sealant in here first. And this again keeps that cold air from coming in. What we've got here is a piece of 2-inch, the industry official name is called Extruded Polystyrene. If you went to a building supply store, you might ask for styrofoam. Usually comes in these blue sheets or pink sheets. I go for 2-inch because 2 gives you an R value of 10, and again, R value is measuring how well this is going to resist heat transfer. For this particular area, when you're retrofitting it and adding insulation, you want to put in an R value of at least 10. You then just fit that in. The next step will be to seal around these edges with urethane foam product. Just want to shake it up a little bit. And this will do a couple of things too. It keeps the warm air from getting in behind this foam and causing any condensation problems that we talked about. And it also just seals up if we missed any leaks with the silicone. It's going to seal that up as well. One more thing I'd like to point out, I used the insulation in the red can, the urethane foam. That's for sealing up larger gaps and cracks. If you're doing any work around windows and doors, if you take any molding off in your house around a window, or in case of new construction, if you're going around a window, use this stuff. This is a lower expansion product. Higher expansion product around a window or door expands so much that it can actually push the framing and the window assembly into the window or the door itself and affect how well the door and the window closes and opens.